This video will be working through problems 4-60 to 4-65. First one we're going to look at is we're going to find the point of intersection for each pair of lines. So we'll break this up into three different problems. On the first one, we're going to use substitution to replace the x value in the second equation with the expression that x is equivalent to in the first equation. So we have 4y minus, and then since it's minus the quantity, make sure you put it in parentheses because you will have to distribute the negative sign. Negative 2y minus 3, and then is equal to 9. So we'll go ahead and solve. 4y plus 2y plus 3 equals 9, and that is because I distributed the negative sign. 6y, if we combine our like terms, subtract the 3, is equal to 6, so therefore y is equal to 1. We can now take y equals 1 and substitute that back in to your first equation for the y value. And so x is equal to negative 2 times 1 minus 3. Negative 2 minus 3 is negative 5. So we're looking for the point of intersection, so we do want to write this as an ordered pair. So x is 5 and y is 1. And it also does say check each solution if possible. So since my solution was negative 5 comma 1, I plugged negative 5 and 1 into both equations, and you can see the work off to the left there. And I did check that it worked for both of them, and it does. All right, on to part B, or question B. We have two equations. This time, this one is set more up for elimination. We could definitely still solve it using substitution. We'd have to solve for one of our variables. But we can go ahead and add the two equations together, and that will eliminate our x variable. And so now we can solve for y by dividing both sides by y, and dividing both sides by 7, and we get y equals 1. Now we're going to take that value of y and substitute it back in to one of the two original equations. And so I'm going to plug it into the first one, and we get x plus 5 times 1. And so that would be x plus 5 equals 8. Subtract 5 from both sides, and we get x equals 3. So our solution is 3 comma 1. All right, and once again we could plug that back in to check to see that we did it correctly. So to check this, we would plug 3 and 1 back in. And so on this one we'd have 3 plus 5 times 1 equals 8. And that's 3 plus 5 equals 8, so you can see that 8 is equal to 8. That works. And then if we plug it back into the second one, that would be the opposite of x, which is 3, plus 2 times 1 is equal to negative 1, or negative 3 plus 2 is equal to negative 1, and once again you can see that negative 1 is equal to negative 1. So checking your solutions by plugging back in. And then we have the last one, which is C. So C, we have 4x minus 2y equals 5, and y is equal to 2x plus 10, so I'm going to use substitution. I'm going to plug 2x plus 10 into the first equation for y, and we will have to distribute. So 4x minus 20 equals 5. So here's a special case where our variables cancel out, and we're left with negative 20 is equal to 5. That is not true, so therefore these are parallel lines that do not intersect, so we have a no solution. And we can't check our answers because there's nothing to plug in. I guess the only way that we possibly could check is if we wrote the first equation in slope-intercept form, and we can compare our two equations to see if they are parallel. So let's go ahead and do that as I'm working through it, and let's see what happens. So I'm almost to the point where I have y by itself, so y is equal to 2x minus 5 halves. So what you're going to notice is the slopes. This slope of the second equation was 2, and the first equation is also 2. So you have slopes that are the same, but their y-intercepts are different. So you are going to have two parallel lines, which means they will not intersect. Question 61. Jay was solving the system of equations below when something strange happened. We're going to solve the system and explain what the solutions should be. So we're not going to use the graph just yet. That's on part B. So we'll go ahead and solve the system by, it looks like, substitution. We're going to substitute negative 2x plus 5 into the y value of the other equation. So by doing that, we would have 2 times negative 2x plus 5 plus 4x is equal to 10. Go ahead and distribute. And we'll notice the variables cancel, and this is probably what Jay was thinking, is something strange happened and the variables cancel. We got 10 equals 10. Now we've done a problem similar to this before where the numbers were not equivalent. In this case, they are equivalent. So what does that mean? So let's go ahead and move to part B first before we try to answer this part of the question. We know there's something strange happening, but let's go to part B now and graph the two lines and see what happens. So if we graph the negative 2x plus 5, the y-intercept is 0, 5. With a slope of negative 2. So we're going to go down 2 over 1. And then we can graph that line. So this will be y equals negative 2x plus 5. And then on the second equation, 2y plus 4x equals 10. We could write that in slope-intercept form. We could plot a couple points. I'll go ahead and write it in slope-intercept form. Subtract the 4x to both sides. Divide by 2. And that would give us negative 2x plus 5. So what I notice is the two equations are exactly the same. So if I went to graph this one, I'm going to get exactly the same line right on top of the other one. And so this equation, 2y plus 4x, is equal to 10. So what happened? Well, the two equations produce the same line. So the two equations have the same graph, or the lines coincide. That's what happened. So when we solved the system, we didn't really in part A get an answer, but we did notice that this was a true statement. So explain how the graph helps to explain your answer in part A. Well, the graph shows us that the lines coincide, so every single ordered pair on this line represents a solution to the system of equations. So the visual helps us kind of see that because our x's in part A canceled, then the solutions are, actually I should say we have infinitely many solutions. So that's the number of solutions that we have. What are they? They're all the points x, y on the line, and you can pick either one of the lines because they're exactly the same. On the line y equals negative 2x plus 5. And so that's how many solutions you have, and those are the solutions. Because remember, it's not just any point. This point out here is not a solution. It's not on the lines. Problem 62. On Tuesday, the cafeteria sold pizza slices and burritos. The number of pizza slices sold was 20 less than twice the number of burritos sold. Pizza sold for $2.50 a slice, and burritos sold for $3 each. The cafeteria collected a total of $358 for selling these two items. Write two equations with two variables to represent the information in this problem. Be sure to define your variables. So we need to define our variables. Once again, when you go to look at kind of the question that is being asked, which is really on part B, determine how many pizza slices were sold, there's two things that they're selling, pizza slices and burritos. So those are the two unknown values. So we'll say, maybe for the first one, we can say let P equal the number of pizza slices sold, and then we can let B equal the number of burritos sold. So those are our unknowns. That's defining our variables. Now we need to write two equations. The first part, the number of pizza slices sold, so that's number of pizza slices, was, so that's equal to 20 less than twice the number, so twice the number of burritos, and 20 less than that. So to write that, because it's 20 less than, we're going to switch the order. So the number of pizzas is equal to 20 less than twice the number of burritos. So twice the number of burritos minus 20. And you have to put it in that order because you are going 20 less than. So you have to subtract the 20 from twice the burritos. So that's the first equation. Then you have a pizza sold for $2.50 a slice and $3 for burritos. So $2.50 per slice of pizza plus $3 per burrito. The cafeteria collected $358. So there's your two equations. Part B then wants us to solve the system and determine how many pizza slices were sold. Well, the way this one is set up, it looks like we can do substitution. So P is equal to 2B minus 20. So this right here, this expression, we will substitute in for the number of pizzas on the second equation. So $2.50 times 2B minus 20. That's the number of pizzas that were sold, plus the $3 per burrito, is equal to 358. So we'll go ahead and distribute. 2 times 250 is 5. So 5B minus 20 times 250 would be 50 plus 3B is equal to 358. 5B plus 3B is 8B. We're also going to add 50 to the other side. And that's 408. And then divide by 8. B is equal to 51 burritos. But it wants to know how many pizza slices were sold. So we're going to have to take this and plug it back in to one of my original equations. I'm going to plug it into the first one. So 51 times 2 minus 20. So that's 102 minus 20, which would be 82 slices of pizza. And so make sure you answer the question, how many pizza slices were sold? 82 slices of pizza were sold. Question 63, a local deli sells 4-inch sub sandwiches for $2.95. It has decided to sell a family sub that is 50 inches longer. How much should it charge? All right, so we want to know how much it should charge for a 50-inch long family sub. And we're going to base this off the information that is already given to us. We know that a 4-inch sub will cost, or it does cost, $2.95. So how much, if we're going to make this work kind of the same way, how much would a 50-inch long sub cost? So I'm going to define my variable. So I'm going to say let F equal the cost of a family sub, which is 50 inches long. There's a couple ways you could do this. You could probably just calculate it based on the information. I'm going to set up an equation kind of as a proportion here, where my proportion is going to represent the length of the sub compared to the cost. So the length of a sub, 4 inches long, costs $2.95, and a 50-inch long sub costs some value we don't know yet. So there's the equation, and we can set it up, as I said, as a proportion because we want the cost to be the same based on the 4-inch sub costing $2.95. You can multiply both sides by the denominator so that we can cancel each of those. So $2.95 times F. And so if we do that on the left side, the 295 will cancel with the 295, and you'll just be left with 4 times F. And then on the left-hand or right-hand side, the F will cancel, but you'll be left with 50 times $2.95. So now we have a pretty simple equation we can solve. Take 50 times 2.95 to get 147.5. Divide that by 4. and we will get 36.875. And so how much should we charge? Well, we want to make sure it's in dollars and cents, so the decimal goes a little bit farther out, so we're going to go ahead and round. So the local deli should charge $36.88. So we are going to round this 7 up to an 8 because of the 5. So once again, make sure you answer that question. Deli should charge $36.88 because we rounded up for a family size sub. 64, we're going to use generic rectangles to multiply each of the following expressions. Now on these, I might show you a generic rectangle on one of them, but we are going to continue to work on the distributive property as well for solving these. So if I have x plus 2 times x minus 5, we can use the distributive property to distribute the x to each of the two terms to get x squared minus 5x, and then distribute the 2 to both terms to get plus 2x minus 10. And if you combine your like terms, you get x squared minus 3x minus 10. For b, y plus 2x and y plus 3x. So I'll show the generic rectangle on this one. Side lengths of y and 2x and y and 3x. So those are your dimensions. Y times y is y squared. 2x times y is 2xy, y times 3x is 3xy, and 2x times 3x would be 6x squared. And so now we can write that out as y squared. Combine your like terms, so the 2xy and the 3xy make 5xy, and then the end is 6x squared. And those are the only ones that you can combine. So that's how the generic rectangle works. Otherwise, you can use the distributive property. On C, we have 3y minus 8 times negative x plus y. So if we use the distributive property, 3y times negative x would be negative 3xy. 3y times y would be 3y squared. Negative 8 times negative x is a positive 8x. And negative 8 times y would be negative 8y. Now, as I look to see what I can combine here, a lot of times our middle terms are being combined. On this one, it doesn't look like we have anything that combined. All the variables are different. X, y, y squared, x, and then y. So that will be your final answer. It might be in a different order depending on how you did it, but since there's multiple variables, we're not going to worry about the order. If it's a single variable, we want to put it in decreasing order by the exponent. And then on D, we have x minus 3y, and then x plus 3y. So same binomial except one's addition and one's subtraction. X times x, x squared. X times 3y, 3xy. Negative 3y times x is negative 3, and then I'm going to put the x first, so xy. And then negative 3 times 3y is a negative 9y squared. And then you can see on this one how your middle term are the same except they're opposite of each other. So those are going to cancel out, and you're left with x squared minus 9y squared. So that's multiplying two binomials together, either using the generic rectangle or the distributive property. Last one, question 65. A consumer magazine collected the following data for fuel efficiency of cars and miles per gallon compared to weight in thousands of pounds. So E is equal to 49 minus 8.4 W. W is the weight in thousands of pounds. And E is the fuel efficiency in miles per gallon. So describe the association between the fuel efficiency and the weight. So from the Y value to the X value, describe the association. So remember when we describe the association, go back and look at those math notes. Is it a positive association? Is it a negative association? And do you think it's strong, moderate, or weak? And so once you make that determination, it is going down. So you can see your line is decreasing. So we do know that. They did draw a line here, so it does appear to be linear. Not strong. The points don't all lie on the line, but you can see that it is going down, so I'd maybe call it moderately in terms of the strength. And I think that's it. And there's no outliers. It doesn't appear that there's anything too far away from the line. So let's write all that information down. And so that's basically what we kind of are looking at. Moderately strong, negative linear association with no outliers. In Part B, Cheetah Motors has come out with a super lightweight sports utility vehicle that weighs only 2,800 pounds. What does the model predict the fuel efficiency will be? So 2,800 pounds, remember the weight is in thousands of pounds, so we're looking for about 2.8, so somewhere in here, 2.8, somewhere around there. And then if we go and we make the prediction, now there's data points on there around 2.8, but we want to make a prediction. So up here on the line, which is the prediction, what does the model predict for fuel efficiency? So it looks like it's maybe right in between 22 and 26, so we could go 24. Maybe it's a little bit closer to the 25, so somewhere around 24, 25 miles per gallon. So for Part B, it looks to be 24 or maybe 25 miles per gallon approximately. And that's based on the model, which is the line, not the actual data. So make sure you're looking, when it says predict, you're looking at the model, not the actual data.